Stanford University.
Okay, well, welcome to Stanford CS 193P, Developing Applications for iOS. This is lecture number 2, fall of 2017. So today I'm going to spend the first 15 or 20 minutes talking about Model View Controller, this design paradigm that I told you we always have to do when we develop for iOS. And then we're going to apply Model View Controller to our concentration app. So you're going to get to see the concepts first, then we'll get to see it in action. All right, Model View Controller, what is it? It's essentially a way we're going to divide up all the objects in our system into 3 camps, okay? One camp, this blue camp, is the model camp. That's a UI independent set of objects that is the what of your app. So for our concentration game, it's the part of our app that knows how to play concentration. Okay, it knows how to match cards, take them away, it knows when to flip cards, it knows all that stuff. It's all the kind of knowledge about the concentration game, but nothing about how it appears on screen. That is all part of the controller camp's responsibility. So the controller camp is the how, okay, how your concentration game appears on screen, right? So model is the what is your app about, and the controller is how it shows up on screen. And the view camp is your controller's minions, okay? These are very generic, usually, UI elements like UI button, the UI view controller even, UI label, all those kind of generic things, UI things that the controller has to communicate with the model to get your game, whatever is going on in your app, onto the UI, okay? So the view is generic minions of the controller. Okay, so those are the 3 camps. Now, MVC is really all about managing the communication between these camps, right? You put the objects in these camps and they have to kind of obey certain rules when they talk to each other. So I've drawn road signs up here. You see the little road signs that are kind of approximating what kind of communication is allowed between the various camps. And let's look at it all in detail. So the controller talking to the model, that's a fully dashed white line going in that direction. You can cross over anytime you want, big green arrow. The controller can talk to the model all at once. It has to be able to, because it is the controller's job to present this what the thing is to the user. So it has to be able to access the model. So that's a big old green arrow, and this is the controller talking to the model, okay? Pretty much unlimited communication to the model's publicly available functionality. What about this direction? Well, similarly here, its minions, the controller has to be able to control its minions. So it's pretty much a wide open green arrow that way as well. And you've already seen a green arrow from the controller to the view in our concentration. It was called an outlet, right? We had an outlet to the flip count label. And of course, we can talk to the flip count label and send anything we want to it to get it to say what we want in the UI. That is the controller's prerogative. So you can see the controller can talk to everybody pretty much all at once. Okay, what about some of the other kind of communication? What about the model talking directly to the view? Okay, that's pretty much impossible. Why is that impossible? 2 reasons. 1, the model is UI independent, and the view only has UI things in it, so there's absolutely no way a UI independent thing could talk to such UI dependent things like the view. Another reason is that these view things are generic objects like a button or a slider. How could a button have any idea what a concentration game is about? No way. There's just no way it would know that. It's generic. So there's never any communication between these two. I never want to see you having any communication between these camps in any of your homeworks or whatever. That's why it's a double yellow line there. No crossing over. All right, that's an easy one. What about the view talking back to the controller? This is probably the most interesting of the communication pathways here. The view can speak to its controller. Of course, it kind of has to, like when a button is clicked or whatever. But when it communicates, this communication has to be blind and structured. It has to be blind because these are generic view objects. The UI button doesn't know anything about a concentration game controller, so when it's talking to the controller, it doesn't really know that it's a concentration game controller. And it's structured in that since we're going to have this communication going on, a generic object has to think a little bit ahead about how it might want to communicate with this controller object. So you already know one structured blind way for your view to communicate, and that's target action. Okay, when we control dragged and created the method touch card, okay, that's target action. And all that the controller has to do is kind of hang a target on itself. That is to say, creates the method like touch card. And then the UI button and other things, they can get this action, and every time the button is pressed, they just call the target. Okay, so this is a very, very simple kind of blind structured communication. But sometimes you need more complicated communication, like you have a more complicated generic view item, like let's say a scroll view. Okay, a scroll view is scrolling around on some image or something like that, and it might need to tell the controller, you know, I scrolled to the end. Am I allowed to scroll down here? Can I scroll vertically or horizontally? You know, it kind of wants to talk to the controller as it's working to do its job. And we do that with these kind of predefined methods that the scroll view defines as part of what's called its delegate. Okay? So its delegate is just a var in scroll view and this var will have some object in it, and all we know about this object is that it responds to a certain number of messages. Most of these messages start with the words will, should, or did, like I will scroll to here, should I scroll over here, I did scroll down to here. Okay, those are classic delegate methods. And the controller, using a mechanism called protocols, which we'll talk about next week, is able to tell the scroll view, I'm your delegate, and all the scroll view will know is that it implements these will, should, and did. It doesn't know anything about it, doesn't know its class, doesn't know that it has to do a concentration game, obviously. It knows nothing. It just knows that the controller will implement that. Okay, so we'll see delegation in about 2 weeks when we start using more complicated UI objects. Now, another important thing to remember in the MVC model is that views, these generic things, cannot own the data they're displaying. In other words, they're not going to have the data they're displaying as part of their instance variables. Now, why is this? Well, imagine that the view is showing your entire iPod music library. And let's say you have 50,000 songs in there. Okay, there's no way, it would make absolutely no sense to have a list view or something, some generic view that lists things, to bring all 50,000 of those things in there. So instead, it uses this same kind of protocol mechanism to have another set of special messages, and they are messages like data, give me the data at, or how many items are there. And the controller implements that so we can talk to the model and get the data for the view. So for example, table view, which is a big scrolling list kind of generic view item that's in iOS. When it's scrolling around on all your iPad music thing, it's just asking for the ones it's currently showing. Right? There's 50,000, it's only scrolling around to showing maybe 10 at a time. And so it's just asking the controller, give me the next 10, give me the 10 here. And the controller's turning around to the model, which is probably a nice fast SQL database or something, and grabbing the data and handing it off to the view. Okay, and this uses this same mechanism where the table view, again, doesn't know anything about this as being an iPod music app. It just knows that it's the data provider. Okay, and we call this kind of delegate the data source. All right, so you'll see that as well. And both data source and delegate very similar. It's just kind of a different set of methods. And these methods are, of course, dependent on the kind of UI element. They're not a preset list. It depends on what's going on in that UI element. Okay, so that's the kind of communication the view can have with the controller. It's structured, it's kind of predefined, things like that. Because of all this communication going on in this direction, we say the controller's job in an MVC is to interpret and format the model's information for the view. That's its primary purpose. Kind of also goes the other way. It interprets user interaction in the view for the model. Okay, it's the interpreter back and forth. It's the center of all communication here. Okay, what about the model? Can the model talk to its controller? Obviously, not directly, because the model is UI independent and the controller is fundamentally UI dependent, so it can't do it directly. But there is a mechanism for the model to communicate, for example, if some data changes and it wants any UIs that are interested out there to update. Okay? And the way it does that is with a model that I call a radio station model. And the model essentially starts broadcasting on a certain known radio station, and the controller up there is just going to tune in, and when it hears, oh, something's changed on the model's radio station, then it's going to use its big green arrow to go talk to the model and get the data that changed or whatever. Okay, so this is a radio station model. In iOS, it's called notifications or KVO, key value observing, and we'll talk about those in a few weeks as well. So there is a way from the model to kind of broadcast, whoa, things are changing. Okay? Now, some people have asked, can a view tune into a radio station? A view could only really tune into a controller or radio station like another UI thing, because a view is fundamentally UI, but even that's pretty rare. Usually the radio stations are pretty much for the model to communicate, hey, something's happening in your data or whatever. Okay, this MVC, a collection of MVC, is generally only used to control one screen on the iPhone. Okay, or on the iPad. Maybe it can control little sub places, like maybe on an iPad, maybe one MVC controls one space, another MVC controls another place, and possibly a third MVC controls another space. But you would never have more than one screen in an iPhone controlled by a single MVC. Okay, so the MVC kind of goes with a grouping of UI, usually one screen, one iPhone screen size worth of stuff. So most apps have tons of screens. You got your settings, you got all the different features in your app, tons and tons of screens going on. So how do we build an app out of multiple MVCs? Okay, multiple MVC apps look like this. Okay, I have a bunch of MVCs up, right? All those purple things are all the controllers. Okay, and when one MVC wants to interact with another MVC, like right here, you see this right here? It always treats those other MVCs as part of its view. So these three MVCs down here are part of the view of this MVC. Okay, so it has to talk to them in a blind and structured way. These kind of act like generic reusable components. Okay, and we're going to see how that works when we start talking about multiple MVC apps a week from Monday. Okay? Now, the main thing that we want to do here is not build our multiple MVC apps like this, where there's just green arrows talking everywhere. Okay? And the reason we don't want this is it's impossible to debug and find out what the heck is going on inside our app. Because if something changes in the UI, we don't know which controller was doing it, or what model gave the data. We're totally lost. Okay? So by grouping them into these nice MVCs, each screen on the phone is very well contained and understandable, debuggable, manageable. Okay? We got all that? So we're not going to do things this way. Do not do it this way, all right? Okay, so the demo that I'm going to do, we're going to do our concentration game. I'm just going to create the model, and we're going to hook the model up into it. Along the way, we're going to learn all these other things. Again, this is a slide you go look at after the demo to make sure you learn these things. I won't get back to the slides, so once again, what's coming up, don't forget that Friday section at 11:30 on Friday about Xcode and debugging. And the next week, we're going to talk about Swift and some other iOS things, and we're going to do it all with the concentration app is a little bit like our demo land. I'll talk to you about something in some slides, then we'll go to concentration, and I'll show you how it actually looks. All right? Here we are, back exactly where we were at the end of Monday, right? We've got our view controller here. We're already along the way of MVC, okay? Right here in this storyboard, that's our V, our view. And right here, this is our C, our controller, okay? So this is our controller, and this is our view. So we need the M. So let's go make the M right now, right off the bat. So how do we make a new class or whatever in Xcode? We go to File, New, File, okay? That's how you create a new Swift file or whatever. And when you do that, it's going to offer you a lot of different kinds of iOS files you want, but really these are the two that are most interesting. This is if you want to create a subclass of a Cocoa Touch class, of an iOS class, like a subclass of another view controller or something like that. But here we're talking about the model, non-UI, so we're going to pick just a blank, totally blank Swift file. This is asking the name. We always name the files that we are creating in Swift. We name it after the most important class that's going to be in that file. Now, I'm going to call my model, my main model class, concentration, okay, because it is the thing that implements the game concentration, so it deserves the name concentration. So that's what I'm going to call it. By the way, I'm not going to put it, you see this group, this is the top level project. You really want to put it in the folder one level down. It's the same folder where your view controller is. That's a better place to put it than at the top level there. It'll work if you put it in the top level, but it just looks nicer to put it down here. All right, so I'm going to create this Swift file. It creates it for us. To make it full screen here, notice that all it says is import foundation, not import UI kit. This is not a UI file. Okay, this is the model, totally UI independent. So I'm going to make my class here. I'm going to call it concentration. Oops, sorry about that. Concentration, okay, is my class. And whenever I build a new class, I always want to think about what its public API is. How many people know what the phrase API means? Wow, almost nobody. Okay, so API stands for Application Programming Interface. It's just a list of all the methods and instance variables in that class, and the public API is all the instance variables and methods that you're going to allow other classes to call. Okay, so it's basically how you use this class. And next week we'll talk about how you actually make things private and public. Okay, but today we're not going to worry about that. But I'm going to basically design my public API. Now, why would I kind of design my vars and funcs right off the bat here? And the reason is because to do that I have to get the essentials of what is it that this thing does and how are people going to use it. And that makes me think clearly as I go into my design here. So I recommend doing this for any class that you design. Okay, so a concentration game, remember we had it up here. What are the essentials of it? Well, one essential is it has some cards, right? And those cards are arrays of cards or something, okay? Not quite sure what, some kind of arrays of cards, whoops. So that's a fundamental part of the concentration game for sure. What can you do in the concentration game? Well, really, the only thing that you're allowed to do as a user is flip the cards over, right? Choose cards. That's all you can really choose cards. All the matching and all that stuff is kind of internal implementation to the concentration game. From a user's perspective, you're just touching on it. So I'm going to need some func that lets me choose a card. Okay? And the argument to this could be either a card, okay, whatever this thing is, which we're going to define in a second, but I'm actually going to make it be a little more flexible. I'm going to make it be the index into this array. So when you choose a card, I'm going to let you choose it by index, and that's just to be a little more flexible to different kinds of UIs that might want to do this. They might be index-based. It's really not that big a deal because you could always just look up the index in this array all the time, but it's a little easier to, to subscript an array and find something than to go the other way around and do index of like we did last time. So that's it, actually. This is the entirety of the public API of my concentration game. Could not be simpler. Now, the only thing here is we got to define Mr. Card. So we're going to go File, New, File, and create another Swift file. This one I'm going to call Card. Okay, put it in the same place as everything else there. All right, again, this is not a UI thing. This is part of my model. So I have two things in my model, the concentration game and this card. What's really interesting here is I'm going to make card be a struct, not a class. Now, what's the difference between a struct and a class, right? Let's go ahead and get the concentration up here in the same time. I can use my manual thing here. Okay, so we've got card on the left and structure on the right. One's a class, one's a struct. Now, in a lot of other languages like C, a struct is just kind of this little thing that holds a little bit of data. It's nothing really that big a deal. But in Swift, structs and classes are almost exactly the same. They have methods, they have vars, very, very similar, okay? So what is the difference between the two? There's two major differences. There's some minor differences we'll run across as we go here, but there's two major differences between a struct and a class. It's very important to understand this. Number one, structs, no inheritance, okay? So you have no inheritance in struct. That makes structs a little simpler because if you have inheritance, you have to kind of worry about all the things you're inheriting and what that might mean for you. A struct has no inheritance, so it's a little simpler than a class. Okay? Number two, and the most important difference, is that structs are value types and classes are reference types. Okay? What does that mean? A value type When you pass it as an argument, put it in an array, even assign it to another variable, it gets copied. Okay, this is very important to understand. It gets copied. And why is it so important that you understand this? Why don't you just avoid structs? Because you can't avoid structs in iOS. Arrays are structs, ints are structs, strings are structs, dictionaries are structs. Okay, these are all structs. When you pass them around in your code, they're getting constantly copied. Now you might be kind of like, whoa, wait a second, that is going to be incredibly inefficient. No, because Swift is super smart about when it passes these things around. It doesn't copy all the bits of all the things of the array when you pass it. It passes it in a way so that it only has to make copies, actual copies, when someone modifies it. Okay, that's called copy on write semantics. And that's the way Swift implements these value types. So structs are value types. Okay, classes are reference type. What's a reference type? That's what you're used to in other languages. The thing lives in the heap, you got pointers to it. When you pass it around, you're not passing the thing around, you're just passing pointers to it. And so you might have a whole bunch of code that has pointers to the same object. Okay, so you see the difference there? So structs are going to take some getting used to because you're not used to when you pass things, it makes a copy. Okay, but you're going to see it provides an awesome semantic that you can really use to your advantage. We're even going to see that here in a small way in our example, but you'll definitely start seeing it when you start using arrays and dictionaries and such stuff like that. Okay, struct card here. What does a card need? Well, same thing. Let's think about its essentials. Certainly a card can either be face up or not. So, and it probably always starts face down, let's say. A card can be matched or not. Probably starts out definitely unmatched. You know, a card also needs a unique identity, right? Because we're playing a matching game, and if we can't tell the identity of the card, we can't match it against another card. So we need some kind of identifier or something, which really could be any type. It could be a string or whatever. I'm going to make an int because it's real easy to make a unique int. So we definitely need that. Now some of you might be thinking, oh, okay, a card also needs the emoji that's on it, right? Like the pumpkin or the ghost. And very importantly, no, it doesn't. Okay? This card is UI independent. So there's no way it can have emoji or JPEG images or anything like that. That's all how you display the cards. This is just how the cards behave, how the game works. So you would never have emoji in here in this model. We're in the model here, not the UI. Okay? Very important to understand. All right, so now we've got all of our, basically all of our API in our model here. Let's get rid of some of these errors. You see that we still have this error, class concentration has no initializers, a very common error that we're used to. That's because this var is never initialized. So how do we create an array of cards? Okay, so this is now you're learning how to create an instance of a struct or of a class. It's exactly the same. And the way we do that is I'm just going to say it equals open parentheses, close parentheses. Okay, so this is just a type. It could be int or string. It happens to be an array of cards. And I'm just putting open parentheses, close parentheses after it. And I could actually be putting various arguments in here. And these correspond to those inits I was telling you about. Remember last time I said a class could have an initializer. It's a special method called init. Can have whatever arguments you want. You could have multiple inits. Okay, well, array has an init with no arguments. And what it does is it creates an empty array. So the array exists, but there's no cards in it. There's nothing in it. Okay? There are other, and you can go look in the documentation for other inits that array has. It has a init, for example, that lets you reserve capacity for a certain amount for performance reasons. If you're pretty sure you know how big there's going to be an array, you can create an array from another array, and it'll copy over the items from that other array. So there are other inits, but the most common array init is this one where you just do nothing. Now, by the way, we're using this kind of easier to understand syntax, but we would almost certainly use this syntax, okay, array of card. That's what I showed you last time. Okay, so I've got an empty array of cards to work with right here. I've got no warnings. So now it's time to go back to our controller and try to start using this model, okay? So we're doing MVC, we're going back to our controller. So I'm going to go back over here, I'm going to go to my view controller. Actually, let's have the concentration on at the same time here, okay? So we've got concentration, I'll make it small, there it is, and our view controller. So how am I going to use my model in this controller? Well, the first thing I want to do is make that big green arrow, okay? The green arrow that points from my controller to my model. And I'm going to do that by creating a var, okay, in my controller. I'm going to call it game. And it's going to be of type concentration. Okay, there it is. There's my big green arrow. I can send any messages I want to game, like I can get at its cards, I can choose a card, whatever, and I'm ready to go. Now, look at the error I get. Our favorite error, class view controller has no initializers, because this is not initialized. Okay, well, how are we going to initialize this? Let's see. We want to do something similar to what we did with this array over here. Let's try that. Let's do concentration. Okay, now, this is probably not going to work, right? Because we didn't create an init with no arguments for concentration, but it did work. Okay, how could this possibly work? Okay, well, the answer here is classes, and concentration is a class, get a free init with no arguments, as long as all of their vars are initialized. And this only has one var, it's initialized. So concentration got a free init. Woohoo, okay, we're initialized. We don't actually need this type. Remember why? Type inference. Obviously, Swift can figure out from that line of code the game is of type concentration. We don't need to put that in there. But this was fun and nice that we got this free initializer, but actually it's no good. It's not good enough. Because when we create a concentration game, we got to say how many cards there are. Because a concentration game has to kind of load up this array over here with all the cards that it's going to use. And we can't assume that a concentration game only has 12 cards like we had on the board, or only has 4 cards like our current UI here has. So we actually need to create our own init. Okay, so let's go, again, make some more space over here, and add an init to our concentration class, init. Now, again, we get to have any arguments we want, and what we need to create our game is we need to know the number of pairs of cards, and that's going to be an int. Okay? So this is the initializer that people are going to have to use to create a concentration game, because we need this. So how are we going to implement this init? Okay, we need to create this many pairs of cards and put them in here. Okay, so let's see. Let's try and create one card. Let card equals, maybe we'll get lucky and we can just say card. Okay, that worked for concentration. Ugh, it didn't work. Okay, why didn't that work? Because if you look over here to our card, let's bring up Mr. Card here. Okay, the card, okay, oh no, it has something that has to be initialized there. Card is a struct. Now, structs get a free initializer as well, but it's different than a class. So this is another difference between structs and classes. Struct, the free initializer they get, initializes all of their vars, even if they're already pre-initialized, like is face up and is match. Watch this. Okay, I'm going to just type card, open parentheses. I'm going to let Xcode show me the initializer, and you can see that it just initializes every single one. So I could do is face up, false, is matched, false. The identifier, I guess I'm going to have to make up some identifier for this thing to do it. So I could initialize a card like that, okay, because I get a free initializer. Classes never get this kind of free initializer. They don't get the free initializer where you can initialize all their vars. That's purely a struct thing. Okay? But this is bogus because these start out false, so why, when I'm initializing, do I have to say again they're false? So I want to get rid of those. And to get rid of those, I have to add an initializer here. So I'm going to have an initializer that just takes the identifier, which is an int, and then I want to set this identifier right here equal to this identifier right here. Okay, well, we got a couple of problems with that. Was trying to do that. One is, this certainly can't be right. Identifier equals identifier, that's just weird. Okay? One thing also notice that in both of my inits, I didn't do an external name and an internal name. You notice that? I only did one, which means both the external name and the internal name is the same. So one thing I could do to fix that is make the internal name be different, like I, and then I could say identifier equals I. You see? This is the external name. Okay, I'm using it here when I call this init. And this is the internal name, which I'm using inside here. And now it knows that this identifier means that one. But you know what? This is kind of gross. First of all, I hate variable names like I. Okay, I is a bad variable name. I just don't want to have it here. But I can't really think of another one here that's any better than identifier. Okay, that identifier is a good name there. So I actually want it to be same internal name and external name. Now, inits are the one method that usually has the same internal name and external name. Okay? Most functions don't, but inits tend to. You don't have to, but they tend to. So now I'm back to saying this. Okay, but it's not, I can't really distinguish between these two. So how can I distinguish between these two? This is the parameter, this is my identifier on myself. Well, I can say self dot. Okay, so self dot means my identifier, this card's identifier. So now it knows we want this one. And so this one is this one. Okay, so that's kind of cool. We got out of having that going on. All right, so let's go back over here again. We're able to create one card. Great, worked good. But we have to specify the identifier for the card. So this really doesn't matter what the identifier is as long as it's unique. So I'm going to create a for loop. So pay attention, here's how you create a for loop in Swift. It's a little different than other languages. It starts out the same, okay, for identifier. This is just for some variable. But you don't say equals 0, less than 20, I++. Okay, we don't do any of that. Instead, we use the word in. And then this right here can be anything in Swift that is a sequence. And a sequence in Swift means anything where you can start somewhere and go to the next one, go to the next one, go to the next one. And that's what a for loop does. It starts somewhere and it goes to the next one, and goes to the next one, and goes to the next one. So what are some examples of sequences in Swift? Arrays. Okay, obviously array, you could start at the first element and go to the next one, go to the next one until you get to the end. String, a string is a sequence. First character, go to the next character, go to the next character, next character. Okay. The one I'm going to use here is a really cool sequence called a countable range. So a countable range is a range, in other words, it has a start and an end, and it's countable. In other words, it knows how to count through it and go to the next space. And there's special syntax in Swift because it's so common to want to make a countable range, and it goes like this. The start of the countable range, dot, dot, less than sign, which means from 0 up to, and not including, the number of pairs of cards. Okay, so this is a for loop that is going to go through. Why is that not cutting? I didn't select it, I guess. Cut, there we go, paste. It's going to go through the number of pairs of cards. Now, there's another kind of countable range creator here, which is dot, dot, dot. That means 0 to here, including this one. So here, if I wanted to use that one, I would say 1, dot, 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 because I only want this many cards. Okay? So that makes a countable range. In fact, if you look at this thing's type, it'll be countable range. Okay, so now I'm going through and creating a card here, but I need another card, so I could say matching card equals the same thing, right? Create another card with the same identifier. Makes sense, right? Now I have two cards that match that I can add to my bunch of cards up here. I always need two cards that match. But you know what's amazing is I actually don't even need to do this right here. I can just do this. Okay? Because when you assign a struct, which card is a struct, to another variable, it copies it. Okay? So matching card is a copy of card. Just by assigning it, it makes it a copy. Now I have a card and a copy of it, so I can say cards, append, that's how you add something to an array, append the card, and then cards.append the matching card. Matching card. Okay, so now I've added these two matching cards to my array, and I'm going to do that number of pairs of cards times. Woohoo, I've got my cards. However, I don't even need this matching card. I can get rid of that and instead just say append card, because putting things in an array or taking them out also copies the card. Okay, so there are actually three cards involved here. This one I create, the copy that gets put in here, and another different copy that gets put here. Okay, so understand that when you pass these structs around, you're copying them. Now later, when we turn one of these cards face up, the copy will actually be a real copy and only one of them. So it's not a pointer to the same card in memory, it's actually two different cards. By the way, another cool way we can do this, different syntax, is I can say cards, which is an array of cards, plus equals another array of cards with those two cards in it. Okay, so plus equals works with arrays. You can add arrays together. And this, putting this card in this array and this card in this array, copies it. Okay, and then we put it in there. And in fact, this array also gets copied because array is a struct. All right, so we got that. This is all going quite well. The only thing I don't really like about this is it doesn't really seem right to me that the concentration game has to pick the identifiers for the cards. Because the concentration game does not care what the identifiers are. All it cares is that they're unique. So really, I don't want to do this. I want to get this out of here and have the card figure out its own unique identifier, right? There's no reason the card could just like pick 1,000,000,007, and that's it. As long as that's unique and it never gives out another card with 1,000,000,007, then it should be unique. Okay, so that's what I want to do. I want this init to not have to take this identifier. Okay, but if this init over here doesn't take the identifier, then we got to figure out how to create a unique identifier here. Okay, so how are we going to do that? Well, I'm going to teach you another cool Swift thing, which is I'm going to create a special kind of method. Okay, it's a static method. Okay, it says same syntax func, but it has static before it, and it's going to get a unique identifier. Okay, it's going to return an int that's going to be unique. And every time I call it, it's going to return me another unique identifier. It's just going to return some unique identifier. We're going to have to make it work. All right? Now, what is a static function all about? A static function is a function, even though it's in the card class, you can't send it to a card. Okay? A card does not understand this message. What understands this message is the type card. You send it to the type itself. So we can think of it as kind of like a global function, a utility function or something that's just tied to the type. Okay, does it make sense? You don't send it to a card. You can't ask a card for a unique identifier. You ask the card type. So, and that's what static means. So here, when I want to call this function, I send it to the type card dot get unique identifier. You see? That's getting it from the card type. Now, how am I going to implement this get unique identifier? Well, I'm going to have a static var, okay, because you can have those too. So that's a variable that's stored with the type, not with each individual card. Okay, these are stored with each individual card. This is stored with the type. And I'm going to call this my identifier factory. It's going to start out with equal to 0. And then in here, what I'm going to say is card.identifier factory plus equals 1. To make it a new unique identifier, and then I'm going to return card.identifier factory. So now I'm returning a unique, every time you call this, it makes a unique int, right? Because it starts at 0 and makes a unique each time. Now what's interesting is I don't really need to say card dot here because I'm in a static method, so I can access my static vars without the card dot. Okay? So that's kind of cool. So that's what I just want to take this little detour to show you how you can do these nice utility methods or whatever, utility vars on a type. Okay, so now let's go back over to our concentration over here because it's got a warning. Let's see what this warning is all about. It says immutable value identifier, this, was never used. It says consider replacing with underbar or removing it. Well, we can't remove it because it's the control variable of our for loop, but we can replace it with underbar. Underbar in Swift means kind of ignore this, or I don't really care what this is because I'm not going to use it. And we've actually used this before. You remember back over here in our view controller, touch card, its external name was underbar, which means don't give an external name when you call this. Because remember, touch card is kind of an Objective-C thing. This is target action. And so it didn't have external name. So we just said, hey, I don't want an external name. Similar kind of thing here in concentration. We're doing a for loop. We still want to do this many times. But we don't care what identifier is because we don't use it in here anymore. Got that? OK, the last thing we need to do here when we're initializing, it's kind of left to do, is to shuffle the cards. Okay? Because if we don't shuffle the cards, then they're always going to be in the same order all the time. It'll be really easy to play the game. I'm going to leave that for your homework. Okay? Your job is going to be to shuffle the cards there. Okay? And it's going to require you to understand, again, this value type, arrays or value types, etc. It's a pretty good exercise to do that, so I'm going to leave that for you. Okay, great. We've solved the whole initialization problem. So now we can go back over to our view controller over here. You can find it. There it is. Okay? And concentration right here needs to specify the number of pairs of cards. Awesome. Number of pairs of cards. And what number do we put here? Right? I guess we could put 4. We know we have 4 cards in our UI. But what if I went and add more buttons? Then I got to come back here and change this 4? Nah, that's really bad. Why don't we just count the number of card buttons? Remember, card buttons, all those buttons are in there. Card buttons.count. Okay, that's how many cards there are, and we'll just divide by 2. That make sense? Let's see, you can see this a little better. Okay, I'm just going to take the card buttons and divide by 2. So if I have 4 card buttons, that's 2 pairs, obviously. Actually, I should be a little careful. If I had an odd number of cards, I probably want to round up. Okay, so if I had 3 cards, I need 2 pairs, so I have 4 total cards. I'll never be able to match that 3rd card, but at least the game will have enough. Now, this is the right thing to do, but oh no, I got a very serious error here. Okay, let's look at it. It says, cannot use instance member card buttons right here within a property initializer. Oh yeah, look, var game, that's a property, and I'm initializing it. That's a property initializer. It says property initializers run before self is available. Oh, remember I told you that in Swift, you have to completely initialize something before you can use anything in it, before you can access any of its vars, call any of its functions, anything. Well, that obviously we're not fully initialized yet because we're in the process of initializing game. Okay, and game is one of its initialized. So we've got a catch-22 here. How the heck are we going to do this where one depends on the other, where one var depends on another? Okay, well, there's a couple of ways to address this, but I'm going to show you kind of a cool one, which is lazy. Okay, if you make a var lazy, that means it doesn't actually initialize until someone grabs it. Okay, until someone tries to use it. As soon as someone tries to use game, then it's going to initialize it. Now, by definition, because of that very same catch-22, no one can try and use game until this is fully initialized. So we win. It works perfectly. And lazy counts as this var is initialized. Okay, counts in that game of getting fully initialized. So it's awesome. There is one restriction about lazy, though, that's not so nice, which is it cannot have a did set. Okay, if you try to add a did set to it, like we did here with flip count, remember that? You're going to get an error here that says class declaration, blah, blah, blah. But basically what it's saying here is you can't use property observers with a lazy var. So if you need to use a property observer there, you need to find out every time the game changes. You're going to have to do it a different way. What other ways could you do it, by the way? Well, you're going to learn next week that there are methods that are called after all these outlets get wired up. Okay? The system will call a method, and in there you could initialize your game. And maybe in the meantime you make it an optional, or maybe even an implicitly unwrapped optional. Okay? A little hint to you there. You won't need that for your homework, though. You'll be able to do this for your homework. Okay, so it's good. Now we have the game, the big green arrow that our controller is talking to our model. What do we need to do next? Okay, well, let's go back and look at our concentration API again, see what we need to do. It seems like there's 2 things. We use this part of the API. We got these 2 left. So let's do this one. Okay, choose card. We got to tell the concentration model when a card is chosen. And we know exactly when that is in our controller. It's right here in touch card. Whenever a button calls touch card, we know a card's being touched. And instead of doing all this flip card with emoji choices thing right here, I'm just going to tell my game, hey, choose this card. Okay? So instead of handling it myself, I'm letting the model handle it. So it's the one, it's figuring it out. But there's something interesting to note here, is that when I tell the model, choose this card, it might change. The game might change, and in fact, I hope it does change because it's supposed to be doing matching and all kinds of stuff. So it's going to change. So now we have to update our view from the model. Okay? Our view is now a little bit out of sync with the model because when we chose this card, that could have caused the game to change. So we need a method like update view from model or something like that. Some kind of func down here, func update view from model. And what's that going to do? That's going to use the other part of this API right here. It's going to look at all the cards and make sure all our card buttons match. Right? whether they're face up, whether they're matched, all that business. We look in the game, find out, and make sure our card button match. All right, so how do we implement this update view from model? Well, I want to go through all the card buttons and look at the game and set it up appropriately. So I could do another for loop where I say for button in my card buttons, okay? And just go through. Now each button will be, if we look at the type of this, it's going to be a UI button, see? Because this is a sequence of buttons. Isn't that cool? All right? But I'm actually not going to do that. I'm going to do something else because I need to look up this buttons index in this card thing. So I'm going to do my for loop by index into card buttons array, which I could do with 0 dot dot less than card buttons dot count. Okay? Everybody understand this? Countable range right here. But I'm not going to do that either. I'm going to show you another way. Card buttons dot indices. Okay, card button dot indices. Indices is a method in array, okay, that returns you a countable range of all the indexes into the array. In fact, if I option click on indices, look at its type, countable range of int. Okay? So that's a kind of a cool way to go through all the indices. And now that I have the indices, I can say let button equal our card buttons at that index, and let the card equal the game's cards at that index. So this is awesome. I've got the button, I've got the card, I just have to make them match up. So I'm going to say if the card is face up, then I'm going to do my face up UI, which is what? That's this one, right? With the white background right there. So let's do that. Otherwise, else, if it's face down, I want the orange background thing right here. Put that there. And now I don't even need flip card. Let's get rid of flip card. Everybody see what I did there? I just made it so that the button matches the card. There's one other thing, by the way. Cards can be matched, right? They have is matched. Remember we put that in a card, is matched. So I need to handle that. And the way I'm going to do that is I'm going to make matched cards be clear, okay? So that I can't see them. If a card is matched, I'm just going to take it out of the UI by making its background be clear instead of orange. When it's matched and face down. If it's matched and still faced up, I don't want it to be clear. I want people to see you got a match. But once it turns back face down and matched, I don't want it to show. So the way I'm going to do that is by doing this, card.isMatched, matched, question mark, either this thing or this. Does everyone know this question mark colon? We have it in C and other languages as well. So here, instead of orange, I want it to be clear. How do you get clear? Well, if you go to any color chooser, if you look at the bottom, it says opacity. That's how transparent the color is. So that's fully opaque, fully transparent. In other words, clear. Okay? So if the cards match, I'm going to make it clear. Now, there's one other error here. It's this. Emoji. Now, this emoji used to be something we grabbed out of this emoji choices based on the index and all that. Okay, I'm going to postpone implementing that here by calling a function emoji for card. Okay, this is going to be a function I'm going to do down here. Let's put this up a little so you can see it. Func emoji for card, which is a type card. It's going to return an emoji, and I'm going to return question mark for now. Okay, we're just going to return question mark. We're going to deal with taking these emoji choices up here. Okay. We're going to put these emoji choices, and eventually we're going to pick one of these emojis randomly and put it on the card. And actually I have a few more emojis here, a little more Halloween emojis. So we're going to pick one of these many emojis right here and put it on the card. But for now, I'm just going to do question mark, because I really want to get back to my UI and make sure I haven't broken anything with all this MVC machinations, right? Okay, let's go back to our model and do something when a card is chosen. So all I'm going to do, eventually we've got to make it match, but all I'm going to do now is have the model flip the card over. The model's just going to flip the card over for now. So here we are in choose card in our model. And so I'm going to say if the card at that index is face up, then I'm going to set the card at that index to be is face up equals false. And else I'm going to make this true. True. Okay? So I'm just going to flip the card over. Everyone believe me that that flips the card over? Yes? Okay, just gonna, if it's face up, goes face down. If it's face down, face up. So that's it. So now when we run our app, there's no emoji, everything's going to be a question mark, but the card should flip over. Okay, and this is the entirety of our UI. Okay, here's our controller. Okay, that's all there is. And here's our model over here, plus we have the card, which is just keeping track of is matched and doing the identifier, right? So let's take a look. Let's run this. Make sure we haven't broken anything. It's always nice when you make MVC and you divide it up, try to make your model just do something simple, just so you can make sure that your MVC is actually working. Okay? So here we go. Sure enough, it appears to be flipping these cards over. Okay? Excellent. So all we need, we have two things left to do. One, get emoji on these cards. Two, make it actually match. Okay? Make it be a real game. One thing is a controller thing, the emoji. Another thing is the model thing. So let's go to our controller right here and do this emoji thing. Now, in teaching you and showing you this emoji thing, I'm going to show you and teach you how to use a dictionary. Okay, a dictionary in Swift, very important class. Does everyone know what a dictionary is? Like a hash table, right? It's just a data structure where you can look something up and get a value for a certain thing. So we're going to use a dictionary, and our dictionary looks like this. I'm going to call it emoji. And its type is going to be a dictionary. Now, dictionary is also a generic type, like array, but you specify the type both of the key, which I'm going to have be an int, because it's going to be a card identifier, and the value, which is a string, an emoji. Okay? So this emoji dictionary, I'm going to look up the card identifiers to get the emoji that goes on that card. Everybody got that? Got to understand that before we move on here. Okay, so how do I create one of these dictionaries? Well, exactly the same as I did with array. I'm just going to do open parentheses, close parentheses, which creates an empty dictionary. So this is a dictionary of ints mapped to strings, but it's empty. Now down here in emoji for card, I'm just going to look in this dictionary and get a card. So let's say let chosen emoji equal, and here's how you look something up in a dictionary. You say the name of the dictionary, open square bracket, the thing you want to look up. Okay, and this had better be an int because this is a dictionary that looks up ints and gives you back strings. And this is going to be a string, right? If I option click on this, is that going to be a string? Obviously not, or I wouldn't be asking that question. Let's see what this chosen emoji is. You'd think it would be a string. Oh, what is that? What type is that? Anyone want to venture? I heard it out there whispered, an optional. It returns an optional. Why is it returning an optional instead of returning a string? Well, of course, because when we look something up in a dictionary, it might not be in there. Okay? The thing we looked up isn't necessarily in there. And if it's not in there, we're going to get back not set, the optional not set. If it is in there, we're going to get the optional set, and it's going to be a string as its associated value, but because, of course, a string is what's in the dictionary. Okay? Everyone understand that looking something up in the dictionary returns an optional. By the way, see this kind of thing? You know how we have that special array syntax, open square bracket type that's in the array? We have the same thing for dictionary. It looks like this. Open square bracket, oops, sorry, delete. Open square bracket, the key, colon, the value type. Okay? So that's dictionaries and strings are the most common things data structures we're using, so we have special syntax for both of them. So that's what a declaration of a dictionary. That's exactly the same as the thing I just blanked out. Dictionary, int, string. Okay, so we could, since we know this returns, this thing is an optional, we could do if let here, but I'm going to show you a different way to deal with optionals. So you know how to do exclamation point, which we definitely don't want to do here, because, for example, this dictionary starts out empty, so if we do exclamation point here, it's going to crash every time, so that's no good. And we could do if let, that would be safe, but I'm going to show you another way that we often deal with something that might be optional, is that we just check to see if this thing does not equal nil. Then we can exclamation point it. Okay? I can return this thing, exclamation point, and it's safe because I check to make sure it's not nil first. Right? So that's another way to deal with optionals. Just check and make sure it's not nil, and then you can exclamation point it. And then the else, I guess, if we can't find the emoji in the dictionary, we'll just return question mark. Okay? So we'll kind of give up and just show question marks. Now, this code is so common to want to get something that's an optional, and if it's set, then use it, but if it's not set, do some other well-defined thing like this, that you can write this with a special operator that looks like this. Return this thing right here, okay? Oops. But if it's nil, question mark, return a different thing, okay? So this is return this, but if it's nil, return this. Okay, very common. That's exactly the same code as this, exactly the same. All right, so we do not need that. Everyone got that syntax? It's very common to do this. Okay, so we're awesomely looking up the card's identifier in our emoji dictionary and returning emoji, hopefully, but we never put anything in that dictionary, so it's always going to return question mark. So how do we put something in the dictionary? Well, I'm going to put them in the dictionary on demand. Okay, as they're used. So every time someone asks me for the emoji in a card, I'm going to check and see if this emoji for that card is currently nil, then I'm going to put an emoji in the dictionary for that card. Okay, so I'm just kind of just in time loading up of this dictionary. Now, how am I going to do that? I'm going to take one of these at random and put it in this dictionary. So let's get a random index. Okay, I'm going to let random index equal something. I'm going to use this nice Swift function called arc4random underbar uniform. So arc4random uniform is a pseudo-random number generator, and it generates a random number between 0 and this upper bound. You see it says upper bound, which is an unsigned integer, 32-bit integer. It will generate a random number between 0 and that, not inclusive of that number, okay? Which is exactly what I want, where the upper bound is how many things are in this array, because I want an index into this array between 0 and how many things are in the array minus 1. Okay? So here, the upper bound, I'm just going to say emoji choices dot count. Okay? Now this is great, but it doesn't work. Okay? I get an error, and what does the error say? It says cannot convert value of type int to unexpected argument type, unsigned 32-bit int. Okay? Arc4random totally works only with unsigned ints, whereas this array's count is an int, not an unsigned int. And Swift never does automatic type conversion. Never. It just never automatically converts from an int to an unsigned int or from an int to a double. You have to explicitly convert it. And so how do you convert types in Swift? This is why I'm showing you this, so that you'll know how to convert types in Swift. You have to create a new thing and use the initializer of that new thing to create one. So here, I want to create a uint32, an unsigned int32. So I have to call uint32 initializer to create a uint32. Luckily, uint32, which is a struct, by the way, just like int, just like string, just like array, just like dictionary, just like card, these are all structs, okay? It has an initializer that takes an int. Whew, exactly what I want, okay? So I can create a uint32 by passing it an int, emoji choices. That's why it's suggesting this fix right here. So I'm going to do that, fix. You see what it did? uint32, open parentheses. The argument to its init is an int. It knows how to do that. Now, we're not there yet, because look at the return value here, random index. It's also an unsigned integer, and that's no good, because I want to use it as an index into this array, and we know that indexes are not unsigned ints, although they probably should be. They are ints, okay, just mostly for backwards compatibility issues. So I need to convert this whole thing to an int. Luckily, int has an initializer that will take an unsigned int and turn it into an int. Okay, so now I have random index here. It's an int. It's suitable for indexing into this array. It's a random index in there. So let's get it. I can say emoji subcard.identifier. Now to put something in a dictionary, you just say equals and the thing you want. Emoji choices sub random index. But this is not quite what I'm going to do. This would work kind of. The only problem with this is I could get two identifiers that use the same emoji. So instead of just grabbing something out of here, I'm going to remove it. Okay? When I use one of these emojis, I'm going to remove it out of here so I never use it again. Okay? So to do that, I'm going to use a different method in array than subscripting called remove at. And I'm just going to remove at the random index. So remove at returns the thing it removed, and so it's going to pick one of these emojis out of here and return it, and I'm going to put it in the dictionary. Everybody got that? Okay, now there's only one other thing here, which is what if emoji choices.count is 0? In other words, what if I've used all the emoji in emoji choices? I've pulled them all out of there. That's going to cause a problem. Arc4 random can't take 0 because it goes from 0 to that number -1, and it's an unsigned int, so it can't be a minus number. So we're going to have to protect against that case. I'm going to say if emoji choices.count is greater than 0, then I can grab an emoji out of there and use it. But if it's less than that, if it's equals 0, then I can't do this, and then I'm stuck with question mark down here. By the way, a cool thing in Swift, you see how we have back-to-back ifs here? Okay? You can put back-to-back ifs on the same line by just separating them with comma. Okay? Then you don't need the embedded ifs right there. And it's nice, especially when things are related. Like, look at how this line of code reads. If the emoji for this card identifier is not set, and if we have emoji choices, then go get one. All right? Okay, so let's see if this works. Let's go ahead and run and see if we're grabbing a random emoji out of there and putting them in one of our 4 cards. It's pseudo-random, by the way, so you're going to see that it's not super random, but anyway. All right, so let's look. Oh, yeah, look, we got a random emoji. Oh, there's another one, little candy. Hopefully these two are the same. Yay! Okay, so it's working. Okay, it's looking it up by identifier, picking an emoji, and using that emoji for that identifier on all cards. And hopefully it's random. Let's stop again. So we got the devil guy and the candy here. Cross your fingers that that pseudo-random generator does it. Let's see. Uh-oh, devil guy. Oh, we got the cat, the scared cat or whatever that is, the screaming cat. Okay, so we're getting random. So this looks like it's working. So we got our UI fully functional here. So the only thing that's left to do now is make this thing play concentration, and that's purely a model thing. So to make that work, I'm going to bring up my model, and I'm only going to put code here in my model. Right now it flips cards over. We'll stop that, and instead we're going to have it play the game. And as part of implementing this, I'm going to use an optional, because I know you're all still, except for this guy who asked this great question, you're all still, I'm not quite sure I understand that optional thing. So here's a case where I'm going to use an optional as part of my fundamental semantic implementation of this method. All right, so here we go. First thing I'm going to do when a card is chosen is I'm going to ignore a card that's already been matched. So if you choose a card that's on the board that's already been matched to another card, I'm just going to ignore it. So I'm going to say if the card that you chose, card of the index, is matched, okay, then I'm not going to do this. So I'm going to say if it's not matched, then do it. If it is matched, then don't do this. Okay, this not, just like any other language, means not, the opposite of this bool. Okay, so I'm going to ignore all matched cards. Now what am I going to do? Okay, there's 3 cases here that can happen. 1, no cards are face up. If no cards are face up, when I choose a card, it just flips it over. That's all it does. Another option is 2 cards are face up, either matching or not matching. If that's true, when I choose another card, it needs to flip those cards face down because I'm starting a new match now. Okay? And the third option is there's 1 card face up and I choose some other card. Now I need to match. I need to see if they match. So those are the 3 options. Okay? So I want to really keep track of the option where there's 1 card face up, because that's where I have to really do the work. I have to try and see if they match. So I'm going to create a var to keep track if there's 1 and only 1 card face up. I'm going to call it index of 1 and only face up card. Okay? And of course it's an index, so it's going to be an int. Now, what's the value of the index of the 1 and only face up card if no cards are face up? Okay, what's the value of that if 2 cards are face up? Ah, interesting. I think this wants to be optional. You see why? Because in those cases where there's not 1 index of a 1 and only face card, then this is going to be not set, because there is no 1 and only face card. So this is a great use of optionals right here. Okay, so all the time in my game, when there's 1 and only 1 face-up card, this is going to tell me the index of it so I can match against it. And all the other times, this is going to be nil, and I'm going to know I don't have to do any work. I don't have to do any matching because there's no card to match against. So what does the code look like to use this? Well, I'm going to say if I can let a match index, which is just a local variable, equal this index of one and only face-up card right here, then I have something to match. Okay? By the way, I want to make sure that that match index of that thing is not equal to the card you chose. Okay? If there's one and only one face-up card and you chose that, I'm just going to ignore that. Okay? You have to choose a different card. Okay, so this, inside this curly brace right here is, check if cards match. And then outside right here is what? Either no cards or two cards are face up. So I can't match. Okay, so in that case, I'm going to need to turn the cards face down and have the card you chose be the only face up card. And then I'm going to set it to be the index of the one and only face up card. Okay, so let's do all that. Okay, let's check if the cards match. Really easy. If the cards of the match index, its identifier equals the cards of the index you chose. Okay, this is choose card at index, right? If they match, then I'm going to mark them matched. Card sub match index is matched, and the cards that you chose is matched. Matched. Okay, so I matched them. Excellent. Now, even if they don't match, okay, what happens when I choose that second card right there? Two things happen. One, I got to flip up the card you chose, okay, because you chose a card that was face down. So I'm going to say cards sub index is face up is true, because you chose a card. I'm flipping it up, of course. And number two, and most importantly, the index of the one and only face-up card equals nil. Because now there are two matched or unmatched, two face-up cards. So there is not a one and only face-up card. So it's nil. So it's perfectly legal to set an optional to nil. Okay, so that's what we do if the cards match. That's all we have to do. Now here we have either no cards or two cards are face up. In this case, I'm going to turn all cards face down. Now they might already all be face down, but so it's a little of wasted work. But I'm just going to go for flip down index in what? In my cards indices. Okay, cards indices. That's all. That's a countable range. Remember, this is a countable range right here. Oops. Of all the indexes of the in my cards. So for each one of the cards, I'm going to say card at the flip down index dot is face up equals false. I just turned every single card on the board face down. But now you chose a card, so I'm going to turn that card that you just chose back to face up. Yeah. Dot is face up equals true. And of course, since I just turned all the cards face down and turned one card face up, what is the index of the one and only face up card? It's this index. I just turned it face up, so by definition, it's the only card. And this, ladies and gentlemen, what do we got here? Oh, this is cards at index dot identifier. Got to compare the identifiers. This is the entirety of the concentration game logic. That's it. That's all that's necessary. Okay, and can you see how having this optional right here kind of made it very simple and straightforward? Because it was easy for me to track the card I wanted to match against all the time. Okay, and it was easy for me to tell whether there was one to match against or not, all contained in one little variable that had a lot of information in it. Okay, so that's it. Let's go see if our app is working. It should just work. I mean, once you make the model do what it's supposed to do, the UI doesn't care. It's just presenting what the model has, so it should just work. So let's try it here. All right, we got this, the cat. Oh, there's the screaming face. Now, what should happen when I click another card? Should flip them all face down. It didn't match, this didn't match, so I should flip these all face down, okay? Turn the new one face up, and now that optional is going to be set, so let's try it. Sure enough, it turned them all face down and turned this one up. Now what happens if I choose a match? Okay, now they've both been marked matched. Now the next time I click on a card, it's going to turn them face down. They're going to be both face down and matched, so they're going to get a clear background, and we're not going to be able to see them. Watch. Bloop. Okay, and this one too. Oops, that was my little thing that shows the mouse better. So what's going on here now, though? Now the game is done. Now in your homework, you're going to add a new game button, which is what you would press at this point. Okay, I want to play another game. Okay. All right. last thing to do here, and we have time luckily, is to add more cards. Okay, because 4 cards is kind of a boring game. So let's go here to our UI. Okay, we've got our UI. I made my, my buttons here be 80 points wide, which I kind of recommend you do for your homework, because 80 points wide, they fit really nice 4 across. Okay, so let's put them up. I'm going to use the little blue lines to help me place them here. Okay. And if you use the blue lines, look, 4 of them at 80 points each, fit right across. And then I'm going to make some more. I'm going to select them and copy paste. Use the blue lines, paste some more. Let's have 12 of them here. Okay, and I need to make sure that everything is connected. So let's look at like touch card. Hey, they're all sending touch card, great. How about card buttons? Oh, yeah, that's right. When we copy and paste, it doesn't put them into that card buttons outlet. Array of buttons, so we need to do that. So I'm going to do control drag. Now, if you really had 12 cards or more than 12 cards, in real life, you probably wouldn't use an outlet collection. You would probably go in your code and go find all these things. You could probably do it in 1 or 2 lines of code, actually. But you really haven't learned enough from me about how the view hierarchy works and all these things to do that. So for your homework, you're just going to have to be doing some control dragging like I am to hook them all up. Okay, they're all hooked up. They're all hooked up. Our flip count label is hooked up. Our UI looks all set. I haven't changed anything but that. I didn't go change any code anywhere. Okay, I just put more buttons in my UI, and because I've built this nice flexible UI that can really handle any number of cards, this should just work. Okay, so here we go. Let's try. Okay, we got candy. Oh, apple, no match. Okay, let's try bat. No match. How about pumpkin? Okay, oh, candy. I think I remember candy. Was it maybe right here? Yes. Woohoo! We found the candy. It was right next to each other. Let's try something else. Okay, how about this one? Apple. No match. Oh, apple. Oh, this is a pretty easy game. I don't know why everyone thinks concentration is so hard. Look at that. Okay, all done. Okay, so why is this game so easy? Well, because you guys have not done your homework yet, which, if you remember, back here, concentration, we have this little to-do. To-do, by the way, is a special comment. If you look at the top line of your thing right here where it shows you which file you're choosing, it also shows you within that file all your methods and properties. And if you put //to-do, it shows up. See? Shuffle the cards. All right. See you on Monday.
For more, please visit us at stanford.edu.